What is a neutron star? Neutron stars are born in supernova explosions. They are stars with a couple of times our sun's mass squeezed into a sphere the size of an earthly city. Here's an artist's concept of a neutron star. The star's tiny size and extreme density give it incredibly powerful gravity at its surface. Thus, this image portrays the space around the neutron star as being curved. Neutron star versus Chicago in the United States. When, at the end of its life, a massive star explodes as a supernova, its core can collapse to end up as a tiny and super dense object with not much more than our sun's mass. These small, incredibly dense cores of exploded stars are neutron stars. They're among the most bizarre objects in the universe. A typical neutron star has about 1.4 times our sun's mass, but they range up to about 2 solar masses. Now consider that our sun has about 100 times Earth's diameter. In a neutron star, all its large mass, up to about twice as much as our sun's, is squeezed into a star that's only about 10 miles or 15 kilometers across, or about the size of an earthly city, like Chicago. So perhaps you can see that neutron stars are very, very dense. A tablespoon of neutron star material would weigh more than 1 billion U.S. tons, or 900 billion kilograms. That's more than the weight of Mount Everest, Earth's highest mountain. Neutron stars are the collapsed cores of massive stars. They pack roughly the mass of our sun into a sphere with the diameter of a city. Here's a comparison of a neutron star's typical diameter with the city of Chicago. It's here in the United States. Here's how neutron stars form. Throughout much of their lives, stars maintain a delicate balancing act. Gravity tries to compress the star, while the star's internal pressure exerts an outward push. The outward pressure is caused by nuclear fusion at the star's core. This fusion burning is the process by which stars shine. In a supernova explosion, gravity suddenly and catastrophically gets the upper hand in the war it has been waging with the star's internal pressure for millions or billions of years. With its nuclear fuel exhausted and the outward pressure removed, gravity suddenly compresses the star inward. A shock wave travels to the core and rebounds, blowing the star apart. This whole process takes perhaps a couple of seconds. But gravity's victory is not yet complete. With most of the star blown into space, the core remains, which may only possess a couple of times the mass of our sun. Gravity continues to compress it to a point where the atoms become so compacted and are so close together that the electrons are violently thrust into their parent nuclei, combining with the protons to form neutrons. Thus, the neutron star gets its name from its composition. What gravity has created is a super-dense, neutron-rich material called neutronium in a city-sized sphere.